Okay, hello everyone. Thank you for being here. So my name is Riccardo Magliocchetti, and today I'd like to talk to you about how to build a simple serverless data pipeline. First of all, I'm sorry, but I'm not that engineer. By trade, I'm a backend engineer. So my goal for this project was to have a simple architecture, better if managed by someone else. And by someone else, I mean other companies and not my colleagues. And so the agenda for this talk, first we'll see an overview of this simple architecture for a serverless data pipeline. Then we'll see a description of the data lake we used, which is comprised of AWS S3, AWS Glue, and AWS Athena. Then we'll take a look at Apache Superset, which is the exploration and the visualization platform we used. Then we'll discuss a bit about data formats. And finally, we'll talk a bit about vendor locking. So let's take a look at the architecture. You can see the graph here. So on the left, we have our application, our Python application, of course. In my case, it was a Django monolith. The application, see the arrow, pushes the data to the data lake, and pushing the data out instead of having someone pulling is, in my opinion, make things a lot simpler. In this case, it was even simpler because the application already was using S3 for storage. So let's take a look at the data lake. First, we have AWS S3 that we use as storage to store the files uploaded by the application. Then we have Glue, which is a AWS service that is used to map the content we put on S3 to a collection of data. Imagine that is, in the end, it's like a database table. At the end of the data lake, we have Athena, which is an AWS service that let us query the data we have on the Glue in SQL. For newbies like me, a data lake is simply the place where you store and process your data. At the end of the pipeline, we have Apache Superset, which again is our visualization and exploration platform. So let me talk about a bit about the context in which this architecture was developed. The team was small, and there weren't any data engineer on the team. Especially there weren't anyone that could take care of the pipeline as a job. The end users of this pipeline are not data scientists or other engineers, are business people. So we need a tool that can be used by business people. Fortunately, this is not a real-time data pipeline because we don't have any real-time requirements. So the data, to make things simple again, is generated once a day. More importantly, we don't generate much data, which is another important metric. We are talking about megabytes of compressed data generated per year. Still, I think this may be interesting for people that works in a small team or small companies. This, of course, was not something that I've done by myself. It's a team effort. So I'd like to thank you, Nicola Martino, for his AWS knowledge, and Bartolo Albanese, who helped me define the data to extract and create all the setup on Apache Superset. Now let's dig a bit more on the data lake. So first a recap. Again, the data lake is comprised of S3 to store our files pushed by the application. We have Glue in the middle to map the content of these files to a collection of data, sort of a database table. And then we have Athena to being able to query this data in SQL. Okay, now let's see the single components. First, S3 is a cloud object storage. If you're not familiar with the term or the concept, imagine being it persistent cache, a big persistent cache that looks like a file system. It's quite cheap to run, But as always on AWS, you have to be very careful about the data transfers you do from and to AWS or the internet. Every cloud platform, if you're not using AWS, offers a comparable or even compatible service. So not much of a lock-in. Then the second service is AWS Glue, which is a serverless data integration service. Being serverless, you pay by the use. And if you're not an heavy user, it's very cheap. We are not doing any transformation of the data once we store it on S3. But if you need to, if you require any cleaning or transformation, aggregation, whatever, you can do here in Glue. You can choose to use your own interface, which is based on Apache Spark, so you can use the PySpark libraries. Or you can cook something yourself. For example, you can, use the Lambdas, which are the AWS serverless computing service. And so maybe you can listen to the S3 bucket events. So when you upload a file, you can bring up the Lambdas, let them process your data, and store them on another bucket. So in the end, the only functionality we use in Glue is the data catalog functionality, which is the visibility to map the data from the files stored on S3 to something that looks like a database table. So it works like we upload the files on an S3 bucket. An S3 bucket, consider it like a directory. And Glue will take care of aggregate all the data and present them as a single table. So at the end of the data lake, we have Athena, which is a serverless query service. That means that it lets you query in SQL the data stored in S3 and exposed by Glue. This is the interface that Apache Superset is using to connect. Speaking about pricing, it costs about $5 per data queried $5 for terabyte queried from Glue. So this was our data lake, and at the end of our data pipeline, we have Apache Superset. Apache Superset is a data exploration and visualization platform. It's written in Python using the Flask framework. Data is accessed via SQL Alchemy and loaded into pandas data frames. And the charts are rendered in JavaScript. It can connect to plenty of databases. At the time of writing these slides, there were around 40 supported databases. And as long as you have a working SQL Alchemy dialect, you can use it as a data source. The platform also offers a SQL Editor, so you can run your own query just to take a look at the data or experiment. In our case, we used an hosted version from Preset, which is the company that employs most of the Apache Superset developers, and so it stewards the project on Apache. So let's see some concepts in Apache Superset. So first, you have to configure a database, one or more database, to retrieve your data. And then, once you've done that, you can choose which database table to expose to the users of Apache Superset. And these exposed database tables, are called datasets. Once you have datasets, you can create charts using the data of a single dataset. And the chart is just a visualization applied to a dataset. So in the screenshot, you can see a graph. The results of the query at the bottom of the picture, and then the fields that was selected to create it. We won't dig into any data, but in case you have questions. Once you have your charts, you can assemble them in dashboards. And on the picture, you see on the right all the charts. And on the left, you have a filter where you can filter all the data that is powering the charts. So you change the filter and the charts updates. Finally, we have the built-in SQL Editor, which is called SQL Lab. This is a tool that permits you to write your own SQL, as you see on top right. You can see the past queries, and on the left, you can see the data you're querying. So, the database table, the dataset you're querying. And so, now it's time for discussing a bit about data formats. So, our first implementation, we used CSV files for simplicity. It's text, and so it's easy to debug. And it's easy because you can use your favorite CLI tools. You can use grep, head, tail, whatever. Or even better, for debugging, you can load them on a spreadsheet. I think it's priceless for debugging data export issue. At least it was for me. Problem is, it's not space efficient. So we moved to another format where we started with ORC or ORC. I don't know how it's pronounced. Anyway, it's a binary columnar format. Being columnar, it means when you query, you don't have to parse all the files, and so you can discard the data you don't need, the columns you don't need. Being compressed, files are a lot smaller, smaller to store, and so cheaper to store, and then faster to query. If you remember, Athena is paid by the terabyte you read, so the less data you store, the less data you read, the less you pay. Problem with ORC or ORC is that the tooling is, at least the tooling I find, the CLI tools I find, are written in Java, which is not our preferred tools to have around, and we were uncomfortable to use these jars found on the internet. And so we changed the format. We moved to Parquet, which is again another binary columnar format. That, on the other hand, has more CLI implementation. There are at least Python and Rust implementation for CLI tools. In our test, the Parquet files were 15% bigger than our C file, but we are happy to pay the price because it was a lot better for developer experience. Also, Parquet has a way bigger ecosystem. It's using interesting projects like Apache Arrow, which is an in-memory columnar format, and Alessandro Molina will give a talk this afternoon, I think. Also, another interesting project that is interoperable with Parquet files is DuckDB, which is an embeddable analytical database. Think of like SQLite, but for analytical workloads. Finally, let me talk a bit about the vendor locking. This solution is based on AWS, and not because I have tons of AWS credits. It's not a sponsored talk, anyway. Because the company was already using AWS, so it made no sense to do something else. And so this architecture is tied to AWS service offering. Still, I think every other cloud provider probably has a different take on how they want you to run your data workloads or to run your data architecture projects. So, for example, if we would have used Google Cloud Platform, probably we would have used BigQuery, because I think it's preferred tools on Google platforms. Still, speaking about lock-in, if you have time and money to handle different infrastructure yourself, you can probably replicate all of this using only open source projects. So you can use Min.io as an alternative for S3 as a cloud storage. You can then use Apache Hive or whatever other Apache project that implements the same functionality there is to ingest the data from the object storage and provide something that Apache Superset can connect to, and Apache Superset as a connector for Hive. And of course, you can host Apache Superset yourself. So, conclusion. To conclude, I think there are tools out there that permits a small team or even solo developers to create cheaply some serverless data pipeline and without much operation overhead. I think it's particularly interesting for small teams or teams without data-specific roles. So if you don't have any full-time data engineer team, I think it's a nice platform. And so, again, in my opinion, serverless makes a lot of sense for a small-scale project. At least for me at least. Debatable, as always. I'll leave you a couple of references. The first link is the AWS idea of data architecture. As you can see, the idea consists of a ton of services, but you can choose only what you need. Then I'll leave you a blog post from Preset on how to set up Apache Superset connecting to AWS Athena. We have done things a bit differently because they used a dynamic crawler to update the data, but we did a static mapping, and so our solution is, costs zero money, so it's even cheaper. Finally, the Superset documentation, if you have any interest in Superset. So, thank a lot. That was all for me. I'm glad to take any question you have. Thank you.
Thank you. We have 3 questions. First one, why did you choose Apache Superset over other BI tools like Tableau or Power BI?
I mean, I have a long history with Apache Superset. Maybe, like, I've been using Apache Superset and contributing to Apache Superset since 2016, when it was very new. So just habit, I think. So I don't have a better answer.
Can you please repeat
the mic? I don't think it's working. I can repeat the question.
No.
No. Try.
Can you please repeat the name of analytical database similar to SQLite you mentioned? Thanks.
Okay. It's DuckDB. Duck, like the one that works.
Do you have any advice on automating testing of such pipeline?
Oh. But in our case, we do most of our testing on when we export stuff, and we kind of assume that AWS still works fine. So we are testing that the data we export is what we expect. But being all managed services, I tend to trust AWS on this. So, not a great answer, but again, since the data is small, we can find problems very easily. So that's it.
Does AWS Glue modify the data in S3 or created replicas?
Data S3, I think that when you store data on S3, it's at least replicated in 3 times in storage, like in some servers. But it doesn't change the data. I mean, I think it's stored, how do you say in English? It's encrypted, but other than that, we don't change the data.
Perfect. How are you handling data transfer fees with the whole solution?
So we are lucky that you have not much data, and so the fees are manageable. If we would have a bigger amount of data, I don't think that I would have used S3. And speaking of S3, just an anecdotal story. We did have a tons of data, a lot of big files, 100 megs for each files on S3. We used CloudFront on front as a CDN. And still, with a CDN in front, the data transfer fees to the outside were a ton of money. And we moved to a fixed service like a DigitalOcean one for stored data. So I don't have an answer. The answer for me is, or you are rich and you can pay, or you move outside. Because I don't know how one can manage to pay a lot of transfer fees that other platforms don't have you pay.
How do you distribute to the business your interactive visualizations directly in Superset or integrated into web page?
No, the business people log into Apache Superset and use Superset. I think they're a bit advanced, the user. Some of them may know maybe a bit of SQL or can poke with the charts building, so they can dig a bit on the platform.
Are you receiving many files during the day and you schedule the pipeline once a day, or you get source data on daily basis and use trigger feature to start it?
Now we upload to S3 once a day, and Glue take care of everything, so we don't have to trigger anything. It works like automatically. So once you upload on a specific bucket you configured, you're fine. You just have to do it once. What's
the role of Glue in your pipeline? Do you use it to infer the schema, or you use it to do some ETL before querying?
We don't do any ETL, any transformation. And the schema, we map it manually once we start exporting the data. So its role is just mapping the data from S3 bucket to a file, to Parquet files in a S3 bucket, to something that looks like a database table to Athena and then Superset.
How would this architecture be reshaped in case of a real-time use case?
Oh. I probably don't use anything like that. But I don't have an answer that can satisfy who asked the question, I guess.
We have still 5 minutes. There are no more questions on Slido. Any question here in the room?
As a follow-up, okay, you can hear me. As a follow-up, you mentioned that you could use events for files being added to S3. Do you actually use it in your pipeline? Okay.
No, we don't use any event notification from S3.
Do you have any experience with it in other projects, namely about the consistency of it? Is it something that you can rely on, or?
I'm thinking if you're using something else, I don't think so. So sorry, can't answer.
Oh, worth asking. Thank you.
No more question?
Okay, thank you.